All right. Good morning, guys and gals. I apologize for having to record this lesson today, but I had to be out for a little bit. Before we read this, try it, because we're still going to continue with our percents. We're going to change from percent of change, which is what we've been working on, and adapt it to percent of error. Now, if you remember, hopefully you remember, for percent of change, we did the percent times the original equals how much it changed. All right, I'm going to read this question, and we're going to see how this can apply to what we've already learned. A bread maker buys a bag of flour labeled as containing 5 pounds of flour. So it had 5 pounds of flour is what it's supposed to have in it. When she weighs the flour in the bag and finds the actual weight is 4.5 pounds. So there was a little bit off. She bought a bag, it was supposed to be 5 pounds. When they actually measured it, it was 4.5 pounds. What is the percent of error from the labeled weight? We've got from, there's our from again, from the labeled weight to the actual weight. All right, let's look at this. We still are going to be looking for a percent. So I'm going to put a percent symbol here. Actually, I'm going to pause before I do this. I want you to think about it about 2 minutes on your own, and then you can talk to your partners. How can I take this and modify it to work this problem? So I want you to try to work this problem based on this formula. All right, you can pause the video now. All right, welcome back. I'm still going to be looking for a percent. But this time, we're not going to be looking at the original. There's not really an original amount here. But there is what it's supposed to be. So this right here is the amount that it was supposed to be, which is the actual amount. No, I'm sorry. I labeled that wrong. It is what the amount is supposed to be. There might be better words for that, but that's how I think of it, what it's supposed to be. Equals, and now we're still trying to figure out how much it changed, but instead of calling it changed, this is going to be how much the error was, how much it was off by. So I'm still looking for my percent, that's my X, times. How much was this bag of flour supposed to have in it? When I'm looking there, it's supposed to have 5%. Or I'm sorry, 5 pounds. So I'm going to put my 5 here. Equals. Then for this part, it asks for the error. If it was supposed to be 5 pounds, but it was just 4.5, it was off by something. So I need to subtract 5 minus 4.5. And when I do that, I get 5/10, 0.5. So I'm going to write that as 0.5. Now, we talked yesterday about how I don't like seeing that in that way. So I'm going to rewrite this as 5x equals 0.5, 5/10. Now, to solve this equation, I need to divide both sides by 5. And it's going to come out to give me x equals 10%. So they made a 10% error on how much flour they put in that bag. All right, we're going to skip and skip. We're going to come over here to the apply it. So I want you to look at the bicycle question. Now, I would take a minute and I would write my formula, just like I did in the other problems, because that's going to help me understand it, know where everything goes a little bit better. So, again, my formula for this was the percent times what the amount was supposed to be equals the air. Oh, you're fine. Don't worry about it. Equals the air. All right, the proper air pressure for Caitlin's bicycle tire is 30 pounds per square inch. That's how much air is supposed to be in a tire. The percent of error in Caitlin's current tire is 15%. What are the possible current tire pressures for Caitlin's tire? So we know that a tire is supposed to have 30 pounds in it. They're telling us the percent. So what they're wanting us to find is what her tire pressure is. They're wanting us to figure out what 15% of 30 pounds is. So this time I do know the percentage. The percent is going to be 0.15 times, now what is a bicycle tire supposed to be weighed at? It's supposed to be 30 pounds equals, and this is what we're looking for. This is the error that we're trying to discover. So I don't have to solve an equation here. I just have to multiply. 0.15 times 30. And I come up with 4.5. Now, here's the tricky part. This is the error. That is not how much her tire actually has in it. So she is going to be off. Her tire pressure is going to be off by 4.5. Now, there's two possible answers for this, because you can have too much air in your tire, or you could have not enough air in your tire. So for the not enough air, I would do 30 minus 4.5. And that gives me 25.5 pounds per square inch. I probably should write that as PSI. That means her tire pressure was off and it was lower than. Now you can also be off in the other direction. You can be more than. So then I would do 30 plus 4.5. And that would be 34.5 PSI. So that tells me I can be more than the tire or less than the 30. All right, let's look at number 7. Jamie estimates it will take 8.5 hours to read a book. So that's an estimate. It actually takes Jamie 10 hours to read the book. What is the percent of error? So we're back to finding that error. So this is her estimate, but this is what it really was. Okay, pause the video, see how far you can get, and then we'll come back and look at it. All right, welcome back. We're going to be looking at our percent times the actual amount equals the amount of error I have. So we are looking for the percent this time because it says what is the percent of error? So that's going to be X. Now our actual amount, that is how long it took her to read the book. Did it take her 8.5 hours to read it, or did it take her 10 hours to read it? The actual was 10 hours. Now you know me, I'm going to rewrite that as 10x. Now for her error, this is where you figure out how far off she was. She said actually was 10 hours, and she estimated it at 8.5. So she went below she underestimated, I'm sorry. Okay, I'm going to subtract, and I'm going to get 1.5. Now I need to solve the equation, divide by 10, and I get x equals 0.15. Now this is a percent. So remember, move your decimal place 2 places, and you get 15%. Okay, let's look at this next one. A radar gun measures the speed of a car at 45 miles per hour. Hopefully you know what a radar gun is. The actual speed of the car is 40 miles per hour. What is the percent of error? So we're looking for the percent again. A radar gun is what the police use to determine if you're speeding. And the radar gun said, hey, they're going 45. But in reality, they were really going 40 according to the car. See if you can set this up. So pause and try to set it up. All right, welcome back. My percent times my actual will equal the error. I don't know the percent, but I do know the actual. The actual speed is 40 miles per hour. Equals. Now, it was actually 40, but they had it at 45. So what was the error? They were off by 5 miles per hour because I did 45 minus 40. I'm going to flip that around because you know me. I like to have it that way. Solve this equation. And I get x equals 0.125. Now we're looking for the percent, so we have to move the decimal 2 times, and that gives me 12.5%. All right, we're going to do 2 more problems. Kiko's estimate for the distance the car will roll is 85 centimeters. And we're getting this based on this up here. Not the work here, but just the word problem. It says students estimate the distance a toy car will roll down a ramp. Greg's estimate is 74. The car rolls 80. So that means the actual is 80 centimeters. What is the percent of error? So you're looking for the percent again. So pause. See how far you can go. If you need to talk to your neighbor, talk to your neighbor. All right, welcome back. So I'm looking for percent times the actual equals the error. My percent, I don't know. But I do know my actual is 80. Now I'm going to flip those around because you know me. Now what was the error? The actual was 80 and he estimated it to be 85. So how much error is that? That's going to be 5 because 85 minus 80 gives me 5. Now I need to divide by 80 and that's going to give me 6.25. I'm sorry. I'm doing it without the 0.0625. Change it to a percent, 6.25%. All right, last one we're going to kind of do together before you do your fluency practice. Ian's estimate has 7% error. What are the possible estimates Ian could have made? So again, percent times actual equals the error. Feel free to pause. Try it out. All right, my 7% error. So that's going to be, the percentage is going to be 0.07. The actual amount, because we're talking about that same problem, the actual amount was 80. So we are looking for the error. There's no variable on this side to solve for, so I just need to multiply. 0.07 times 80. And that gives me 5.6. Now this is not a percentage. This is the amount that Ian was off. And remember, you can be off either above the actual or below the actual. So that means he's got 2 choices that this can actually be. If he did the over, he would do 80 plus 5.6, which gives us 85.6. If he underestimated, you would do 80 minus 5.6. And that's going to give you 74.4. So it could either be an overestimate or an underestimate for that one. All right, we're going to get your books. We're going to hand out a book. You may or may not get your own book. You don't need your own book. You are going to tear out page 70, I believe. And then I'll collect the books back and put them up. Please behave. Please do your work. I'll see you later.